Well, thank you for joining us today on this podcast talking about battery technology and construction equipment. We all feel there's a lot of great information and new techniques coming into our industry, and we're here at Vanguard Battery Systems to learn more about how battery technology is coming into the construction industry. We have two experts with us that can help us learn about the techniques and innovations coming towards us, and how OEMs can integrate these systems into existing equipment.
My name is Dave Schulenberg. I'm the Director of Product Management here at Vanguard, in charge of our battery and electrification initiatives.
I'm Stephen Avery. I'm the application engineer for Vanguard batteries. So my job is to work with our OEMs, customers, in integrating our batteries into their applications of all sorts, and make sure that everything's working properly.
Well, contractors are hearing a lot about lithium battery power systems. They're bringing it into the construction industry. What are the trends of how electrification is coming to all types of equipment that our contractors use?
Yeah, we're seeing technical advancements everywhere with lithium-ion batteries, right? And a lot of that's filtering down from the automotive area, and we're seeing specifically a lot of effort being put into cell development. So when we talk about power and capacity of the new cells that are coming out, they're getting better and better every year, right? So what that enables us to do is look at applying that same power to new applications that weren't maybe viable a few years ago. And then similarly, we're seeing huge advancements in charging infrastructure. And everybody hears about Tesla and other companies like that investing in charging infrastructure. And that type of infrastructure is going to enable us to power new and larger vehicles than we've ever looked at before.
And when you mean vehicles, you mean all types of construction equipment from ranging from.
Yeah, certainly. It's not limited to either what we would traditionally think of as like a light electric vehicle, or a power tool for that matter, right? It's everything in between. So we can start talking about walk-behind equipment, handheld equipment, ride-on equipment, or even autonomous vehicles or equipment at that point.
Yeah, I think it's amazing how contractors are accepting that and bringing it into their workplaces as well, right?
Mm-hmm.
So that's a big deal. But one of the most important things about contractors and construction is safety. So how does the new battery systems affect, how do they increase construction safety?
Well, we talk about safety at the pack level a couple of different ways. First of all, obviously we're looking at the safety of the power source to begin with, and we're using multiple systems, both, what we call a dumb system on the battery for safety, or something that doesn't require, intelligence. But then we're also looking at smart systems. So we're certainly making smart batteries today, and we call it a smart battery because there's a battery management system on board the battery. And that battery management system is constantly evaluating the state of the battery, how it's being used, its temperature, and a bunch of other different things going on inside of it, and making sure that that battery is kept in a safe condition at all times. Now, what we can do with that intelligence on board is use it to communicate with the rest of the vehicle, right? So we're using a CAN bus system to communicate with the rest of the vehicle. We can broadcast out to the vehicle what's happening with the battery, as well as enable the rest of the components in the system to work with our battery and create a generally safer product based on whatever the application needs are.
So an OEM considering electrification should feel really confident that whatever durable product they deliver to the marketplace will be as probably even more durable and more safe than it was before, right?
Yeah, absolutely. There's a lot more capability on board by making it a smart product, and that gives you all sorts of new opportunities to look at how you can make that product safer, or how you can change the way it operates.
But one of the challenges OEMs have is that they've established their brand and with their customers. They've been known for the durability of their product, and when they switch to electrification, there's got to be a concern. How do you help them solve that?
Yeah, so we have a lot of experience with our background in engines, right? We've been powering construction equipment in these applications for many, many, many years. So we've got a lot of the same talent, the same expertise in powering the equipment that has been powered with petrol or other for many years. We're bringing that knowledge into battery. So for example, we look at our battery today and we say, we know that job sites are really tough, right? Job sites are clearly, construction job sites are clearly one of the toughest applications of any power source. Concrete dust, for example, is one of the worst, right? Whether it's made by a grinder, a cutoff saw, or even a trowel, that's some of the finest dust you can get, right? So we test our product to be sealed for that level of dust intrusion. Similarly with water ingression, we're always worried about water and electricity, right? Everybody knows that's not a good mix. So we're always looking at that, and while nobody would ever recommend that you go up to a piece of electrical equipment and pressure wash it, we know that there's gonna be a new guy on the crew that probably does that, right? So we'll never recommend you do it, but we test to make sure our equipment can survive that.
So going back to the fact that electrification is occurring across all different types of construction equipment and contractor focused equipment, there's a wide range of things that has to be powered, from walk behind power trowels to steam jennies to you name it. So how do you focus on making sure that the right power is available for that type of application?
Yeah, that's a great question. And what's really interesting about it is we have to kind of re-rack the way we think about applying power, right? So now we go from a world where in petrol, where the power is easily refilled, or you can fill up the gas tank again quick, right? And that's always been the concern with batteries. What's my runtime? How long does it take for me to recharge, et cetera, et cetera. So what we do is we work with OEMs, and we generally answer the first question is, well, how long can I get this to run for, right? And we get that first question, and we take a step back and say, well, hold on a second. Let's look at what's the real power utilization of the application, and how long does it actually really run for in a day? Because if you go talk to any contractor or anybody who's used the product and you ask them, well, how long do you need this to run for? You're always going to get, well, a full day, 8 hours, right? And the reality is, no tool, very rarely is there ever a tool that's used for 8 hours a day consistently at full power. So we take a look at how is the tool used, how often is it used, and then how much power is being used at that given point in time. A great example of that is, say, your car, right? You can have a 200 horsepower car that you're driving down the road, right? When you're going down the freeway, you're probably only using 10 to 15 horsepower of that 200 horsepower going down the freeway. You rarely use that all the time. And the same goes for most petrol powered equipment. In battery equipment, you don't use all the power all the time. So you have to understand that. And, we'll talk about it a little bit more later, but that's a lot of the work Stephen does in taking existing equipment, measuring the power utilization and how it's used, and then figuring out how much energy is needed for the application. Another great thing to think about is this actual utilization time. So, we work a lot with commercial cutters, commercial lawn care companies. And, if you go ask those guys, you get the same answer. Well, it's got to run all day. And to the outside person, that actually kind of makes sense, because you see these guys and they've got big lawns they're cutting, big jobs, and they've got multiple per day. And boy, if there's anybody out there that could actually run a piece of equipment all day long, it's probably got a guy running a big ZTR, right? So to test that, we put some data recording equipment on a fleet of these pieces of equipment a few years back. And what we found is the average runtime for those ZTRs is actually only about 3.2 hours in a given day. and the highest runtime on any given day was 5.8 hours. And that includes idle time, right? So when we start to think back to how is a product actually used, we need to start challenging those accepted norms of how a product is used.
And utilization, but what you were referring to is how the OEM is understanding how his customer is using that product, right?
Yeah, yeah, absolutely. And you know, you think of again, think to a construction job site. Very few things are ever actually used all day long continuously. That ZTR example is great. And if you think about it, some of the other things we've looked at, like say a concrete saw or a screed, um, think about the process of the job site. Some of those are used less than 15 minutes on average in a given day, right?
Right.
So the actual amount of energy needed is pretty low.
So how does idle time utilization fit with each other?
Right. I mean, idle time on an engine, you're still burning fuel versus on a battery product, you're not actually using that energy. There's very little loss while you're just sitting there. Not to mention, we can also make systems even more efficient beyond the power source, whether it be an engine or a battery, when it is an electric product, because we can actually put motors right at the source of the need, the chore, wherever it's at. If it's a trowel or any other application, you could actually put a motor right on there and eliminate the needs of some belts or other clutches that can actually add an inefficiency to the system. In the gas world, people didn't really care about those inefficiencies because they just kept filling up the tank throughout the day. But in the battery electric world, you really do have to actually kind of look beyond the power source for efficiencies as well.
So one of the key aspects is working closely with the OEM to really understand how their powertrain has been, how their existing powertrain is set up and how to convert it over to electrification, right?
Yeah, yeah, absolutely. It's a huge focus. I know Steven spends a lot of time working and helping OEM select the right components downstream for their products, whether they be motors or motor controllers and anything that goes with it.
Yeah, and I guess each OEM probably has a preferred way they approach their powertrain, right? So everyone's unique. They've spent all of their research developing that. And so you're able to help them make sure that whatever investment they've made in their development can be continued on, right?
Right, absolutely. We're used to working with customers that they all, as you said, they all have their own kind of secret sauce to make their application and their tools work great. And that's why their customers come and buy their equipment. What's great is we're able to learn how to assist those OEMs, and we learn what they care about and how we can best support that. And that's happened for years on the engine side, and that's what we've been doing here as well on the battery side. I work in the power application center here, and that's our job, is to work very closely with the customer to learn their needs and ensure that they're going to get enough power from us, get enough runtime, and then have a good end user experience, which is really important.
What are the important things that the OEM ask you when you get involved in this?
Right. So one of the stuff that we really need to get down to, as Dave mentioned, is we really need to know what their actual power needs are. So we have to know how much power we have to supply, because batteries have an ability of a certain amount of power to give, and that is both in a peak power situation as well as a continuous power. And what's neat about batteries is we're actually able to provide a huge amount of peak power for the amount of continuous power we can provide. So for a short amount of time, we're really able to give a lot of power. But then beyond that, we also have to say, okay, giving this much power and this load profile we create, we can then calculate how much battery capacity they need based on the runtime they need per day or charge cycle, and then also determine over the life of the battery and the application, what's needed so that as a system gets older, that still meets the customer's needs. And then beyond that, we also make sure that their system's wired correctly. We've been talking about, we also have CAN bus communication. So how the batteries incorporate into the controls and how you operate the equipment, we're able to provide a lot of information that can actually be used to make the controls really smart, very fluid, and make the end user experience very even easier than it used to be and a lot smoother. So incorporating all of that is important, and we have to work really closely with the OEMs to make sure that everybody's on the same page and that everything goes well.
There's got to be a period where the machine goes in the field for prototype testing, right?
Absolutely. So yeah, we kind of covered up the initial part of us figuring out and estimating and doing our best guesses on paper, but we actually have to see it in the field. And what's really neat, once again, with it being a smart product, we're able to easily record all the information that's going on while they're testing, and this could be done anywhere. It's in the field around the world, and we're able to then get that data back and crunch huge data sets to really understand how that application performed and make sure that we're properly powering it, as well as it's meeting their expectations in terms of runtime, power output, and we can use sensors. We have capabilities of measuring vibration, sound, heat, all sorts of things, so we can make sure that we're staying within the capabilities.
So what you're thinking, so if an OEM is working towards electrification, you really have a whole list of best practices and best experiences that you can share with them, so they're not reinventing the
Yes.
wheel as they go down this process, right?
Right, absolutely. We've got the expertise, obviously, in the batteries that we're making, but that's also the benefit of our company having a deep history in the engine world, in this industry, that we also understand the needs. We're not just like a fresh startup battery company that's trying to learn the world. We know what these companies require. So that's one of the benefits of working with us, is we have that expertise as well, so that we know that we're going to meet their needs.
You mentioned before about the ability through the pandemic to reach out and see what's happening around the world. So so really you're able to almost have complete diagnostics through the prototype and even beyond, right?
Yeah, that is correct. You know, in the past, it's kind of relied a lot on OEMs having some data logging capabilities, or we've definitely handed out data loggers for people to utilize in the field. But on top of that, we also have our diagnostic tool. And this diagnostic tool is the same one that we use for our EFI engines, actually. It just uses a different cable to plug into the battery. And this allows a very user-friendly interface for OEMs or dealers or distributors to actually plug into the battery, and they're able to check, what the state of charge is, if there's any error messages, all the voltage and current. They can run it. They can run the application with the computer hooked up and see exactly how the application works, as well as they can also update the battery firmware using the tool. And it's just as easy as, if you have diagnostic equipment to plug into a computer for your car as well. So we can also use those CAN messages in remote systems with the OEMs. We can integrate that with them, but we also have this hardware available to OEMs as well to help assist development and troubleshooting.
So for an OEM entering, this is almost like almost a pre-packaged approach. They're not redesigning what they're doing. It allows them to be really simple to what happens, right?
Absolutely.
Yeah.
So there's one really important part to that, just like Stephen had said. It enables our field service diagnostics, right? Which is, like you said, it's a very automotive style tool that you plug in and it reads out error codes. But the other thing that we do that's kind of unique is we have a programmable CAN bus. So we've got a lot of companies that have their existing network, and we've got this secondary CAN bus that we can program for their existing network, so they don't have to adapt to us, right? So we can adapt to them. And we actually, in some cases, we've got some OEMs that already have their own tools, right? We adapt to their tools as well. So we've got some customers that are using their own diagnostic tools because they've got a vehicle level diagnostic tool. And we can output all of our stuff in their language or in their codes and work with them that way.
So for an OEM, what you're really saying to me is that you're saving them money because they're not reinvesting in recapitalization of their control system, and more importantly, they're able to bring a product to market faster.
Absolutely.
And in today's, that's a huge thing, right? That's And I guess so in bringing the products to market faster, there is a demand for electrification, right? There's a lot of reasons why all this technology is gaining acceptance in our industry, right?
Yeah, there's certainly growth due to the general knowledge of electrification. Certainly, everything going on in the automotive market brings awareness to the capabilities, and helps educate everybody on what batteries are really capable of doing. But there's growing applications that are really driving a lot of the adoption, and there's many different ones, but there's really two leading ones that we like to talk about. Number one is indoors, right? Everybody knows that you can't operate combustion equipment indoors due to the risks of noxious gases and things like that. Um, and a lot of those applications had been plug in the wall previously, right? But there's a huge limitation to plug in the wall. Number one, you've got a cord attached to you, right? So you've got to do all this cord management, and we've heard certainly there's a lot of expense to cords getting cut, a lot, and there's a limit to how much power you can get out of the wall. Well, the great thing about battery is that we can get a ton of power out of battery. Like Stephen mentioned earlier, you have a kind of a regular power rate that you can get out of it, but very unique to battery, you can get this basically 4 times the amount of power for a short period of time. So if you've got unique work that has like little intermittent loads that you've got to handle, battery can do things that you haven't been able to do before with plug-in equipment, right? So we're seeing a lot of really cool applications there. And then the other thing that's coming up is noise ordinances. You're seeing a lot of municipalities coming up and saying, hey, you've got this decibel limit that you can't exceed now. And it's either happening all day long, or sometimes it's just in the mornings and evenings. And battery gets us into an option where we can reduce our overall noise footprint and serve those communities, still get the work done, and not violate the noise ordinances. And there are even applications where there maybe isn't a noise ordinance, but you still don't want to upset the neighbors really early in the morning or really late at night, right? And battery allows us to get contractors to be able to do that work, early in the morning and late at night. And there's a lot of contractors out there, especially in areas where you have like seasonal work opportunities. Let's say, in the northern part of the US where winter comes and guess what? Nobody's pouring concrete anymore, right? Those guys work their butts off all summer long, and they want to get as much work time every given day as they can to make the most out of their season, right? And battery allows them to do that, allows them to get more time in the morning and more time in the evening running quieter.
I appreciate you taking time to share with us the innovations that have come about in the last 5 years with regards to battery technology and how it applies to construction equipment. I guess my takeaways is that this is a technology that OEMs should want to know and how to bring into their market, into their fleets and offerings to their contractor customers. And I think that the technology, the Vanguard, and the innovations of Diagnostics and CAN bus are something that OEMs would want to investigate more. Dave, you agree?
Yeah, absolutely. We're certainly here to help. We've got Stephen and a whole team supporting him and others like him and across the globe, ready and willing to help out in that journey.
So if someone is about to take that journey, what's the best way to reach out to you guys?
Well, the easiest way is probably to go through our website at vanguardpower.com. There's a contact form there, and if you fill out all that information, certainly somebody would be able to get in touch with you very quickly after we get it. There's also, if you have an existing relationship with somebody at Briggs & Stratton or Vanguard, you can reach out to them and they'll get you in touch with the right people. Otherwise, lastly, there should be some information coming up on the screen right now that would give people the ability to contact the right people, and we can get in touch.
Well, again, thank you for your attendance on this podcast. Hopefully you'll have learned what we've learned today. Thank you.